So now, without further ado, I'd like to welcome Agus to our virtual stage.
All right.
Thank you.
Thank you very much, Bruna. Thank you for the introduction. And thank you everybody for joining us wherever you are. It's good morning for many of you in Asia Pacific, and probably late night, a bit late in Europe, and in the US as well, for the East time zone. So with that, I'm going to share my screen, and then we can start the session. Let's see, screen one, share. All right. I hope you can see my screen. So the title today is Beyond the Black Box, that the title that Bruna chose actually, and making GenAI ready for banking and finance. So this is hopefully will be a stimulating conversation. This is something that I have been thinking for some time since my day at Wells Fargo, as well as after my retirement, and working together with H2O on this subject. I would like to acknowledge my co-developers, Srinivas Nepali and Mikhail Malalava. They were tirelessly making what I think in my mind become reality. So with that, I'll start with this, probably this first slide. AI is a guessing machine. It's a powerful but can be unreliable. It's very useful for low-risk use cases when you want to do create a background slide, or you want to use it for mindless entertainment. It can be wonderful. The tool, as you may already experience, it can be brilliant in one area, it can be so bad in another area. So now we want to use them for high-stake use cases where mistake can cause real harm. This is in cases in finance and medicine, in high-stake area where mistake can be consequential. So that's the topic that you want to do to discuss today. How can we do it? And with that, let's start with this. This is probably something that's a little bit fun to start. This is the typical use cases in banking. In banking, people use this to do complaint summarization, etc. And probably very tempting to do a zero shot or a few shot to use GenAI to do complaint classification. In banking, particularly in the US, complaint is very, very highly regulated. From the minute people complain to the time of resolution, it has to be done within 10 days. So big banks, they probably get a phone call, a million phone call every month. They have to process it, when their complaint has to be resolved on time. So let's start with this fun statement, the first one, and see if this will be classified as complaint or non-complaint if we ask GenAI. So the statement is, I really appreciate the time your team take to ensure everything is processed correctly. I notice my refund request is still pending after 2 weeks, which is longer than I expected. I'm sure there's good reason, but could you confirm if everything looks good on my end? So it's a very, very polite things. People can think about this is a complaint or not complaint. So in a highly regulated entity, it has very specific definition of complaint. So if we casually ask LLM, this one I asked ChatGPT, and ChatGPT say it's not a complaint. The customer because it has appreciation statement and all of those things, very polite. So this seems like request for information and clarification, and it's not complaint. Well, it's interesting. Now, the second part, I asked again, okay, differently, and it's complaint, even though it's polite. Right? So this is what GenAI will do to you. Where you ask, it will follow whatever you ask. And I made a post in LinkedIn a few weeks ago about this one as well, thinking that I call it overfitting to user input. Uh, so the the finicky result or outcome of GenAI, if we want to use it as a judge to say whether this or that, it can be very problematic and depend on the prompt and the example and all of those things. So the difference that we did on this, that I did on this, is really just the system prompt. Two different system prompt, it can produce very different outcome, and it can be very inconsistent too. So if you want to use this as a zero shot or as a few shot as a judge, it can be problematic. As a classifier, it can be problematic. So that's the type of thing. And this is another example. It's the same thing. And it just have a fat finger at the end. It has F word, F character at the end. And the Gen AI will say this is a complaint. Okay. So this is the type of thing that we have to deal with when we're dealing with Gen AI. Now, with that, because of that, when we want to deploy it in high stake application like banking, we have to test it. We have to test it thoroughly, or we call in banking MRM, model risk management has a term called model validation, right? Independent function run by independent people to do model validation. If we look at model validation, at the end of the day, with all the testing that we want to do, model validation is really to bring the unknown to the known. We want to know what can go wrong with model. So the focus of model validation is not about model performance only, but more importantly are really the risk, understanding the risk. What can go wrong? How wrong can it be? What is the source of the failure? And how to fix it. So that at the end of the day, that's model validation. So model validation is not just simply a bunch of testing, but the focus of testing need to really identification of model weakness. So that's what we want to do, because if we know the risks, and when we use model, we always taking risks. We always taking model risks. If we know the risk and we know how to manage that, we will take the risk, because that's what banks do every day. They're taking credit risk by offering loan. They're taking market risk with liquidity, with the market risk as well, taking a position, facilitating customer, and all of those. So bank will take risks if they know how to manage it. Now, the same thing, we use model. Is always we have to deal with model risk, because all models are wrong. So but they are useful. So how can we use them and manage the risk? That's really the crux of model validation. Now, comprehensive validation of large language model, I call it impossible. Validating Llama, validating OpenAI, ChatGPT, validating Claude is impossible, because no control on the training data, is everything from the internet, no control on the input, infinite prompting and possibility, and wide range of output. So people do all kind of benchmark today, but they're completely useless. All those benchmarks are completely useless. It has no meaning because it's only testing for specific prompt. So when we want to use it, when we want to test we want to understand what are the potential weakness and things, it will never be comprehensive. And this is problematic in model validation and in banking in particular, because model validation must be credible, must be able to understand what's going on and what will be the risk. But comprehensive validation of RAG is possible. Why? Because RAG is bounded to this is the document, this is the source of document, and this is going to be used for a certain purpose within the scope, in the scope of all this collection of the document. So the collection of document that is in a RAG system bound the system. So if we want to use it for something else, we have to test it. Okay, we want to use it for RAG for different application, we have to test it for that. So it's not general purpose RAG, but RAG for specific application, we can test it because it's bounded. So we can test it in terms of information retrieval. We can test it in terms of the groundedness, completeness of the answer, and all of those things. We're going to talk about that a little bit later on that. So we need to bound it. Once we bound it, this is the scope, then we're going to test it. So in banking, we don't test LLM, but we test for specific use case. And RAG is RAG for certain documents, certain application. We test it for application per application. So it's not general RAG, but testing it for specific use cases. With that, model validation is still a challenging task for GenAI. One is because unlike predictive AI, test cases are not available. In predictive AI, we split the data, training and testing. We can test and validate model based on the data that we don't use to build model. So we can do model validation based on that. That's in predictive AI, and that data is available. In Gen AI, the data, the testing are not available. So we have to create. The question is, how do we make sure that the test cases are comprehensive? How do we make sure that we have comprehensive coverage? If this is a collection of documents, we're going to test them all. How many and what kind of problems that we have to deal with to have comprehensive coverage? How are we going to evaluate that? Because we have multiple imperfect evaluation metrics. We want to use evaluation techniques that we're going to talk about later that is transparent, traceable, but each evaluation matrix will not be perfect. So how do we deal with multiple imperfect evaluation metrics? The common question is, can we afford to create a perform comprehensive test? This is the thing that we're going to talk about today. How can we automate some of the testing, but we still have high confidence on the outcome? Because testing comprehensively manually will not be, it will be very, very cost prohibitive and very, very time consuming. So here it is. This is the thing that I talk about, model validation workflow. It has several steps. The first step is test generation. We want to make sure that the test is comprehensive in terms of topics that's in the document and query types. So how can we generate? We'll talk about that in a little bit. How do we generate? How can we create test cases that are comprehensive in terms of topics and query types? Once we have test cases get generated, We have the set of test cases that we want to do. We're going to do evaluation. How are we going to evaluate how good our RAG system is? And with that, we need a matrix that is transparent, traceable. So as we're going to talk about later, I am not a fan of LLM as a judge. As an example that I give at the beginning in terms of complaint detection, using another LLM as a judge is not very sound. So how we're going to do something that in regulated industry that require transparency, how can we create matrix that is transparent but also reliable? So we're going to talk about functionality and risk or safety metrics a little bit later. Once we do evaluation, because we want to do step 1 and 2 in semi-automated way, without or with minimum human intervention. Now we need to have the third step, which is human calibration. Now we're going to sample the test, we're going to perform sampling, and we're going to calibrate with human label. So we have to have small sample, something that's doable, with human evaluation, then calibrate the big comprehensive test that we have, calibrate it with human calibration, so that we can apply to the rest of the test cases where we don't have human label, and we can draw conclusion with that with confidence. So the step 3 are really important to support the automated testing. Step 4 is really the crux of model validation. Weakness identification. I cannot say this one enough, because a lot of people just do evaluation, calculate, get metrics, aggregate metrics to get the in terms of performance, in terms of groundedness, in terms of relevancy, and all of those things at the aggregate level. That's not how model validation should be. Model validation should really focus on model failure, how the model will fail. We interested on the risk. We interested on the tail side, where the model will fail. What can we do to approach it in systematic way, to identify what topics model fail, what kind of query that the model fails. So that's kind of things that we really need to focus on, identification of model weakness. And then we still also have to do what we call as robustness tests. Now, we have test cases generation before, we need to make test cases that's more challenging, the input more problematic, is the model will still be able to do what it's supposed to do. That's robustness test. So model validation comprises of 5 steps: test generation, evaluation, human calibration, weakness identification, robustness test. So we understand the risk and the problem so that we can fix them. Now we're going to use a few tools throughout my presentation. Test cases generation, we are going to use a large language model to help us, and we're going to see why. But we don't use LLM as a judge, okay? But we can use LLM to generate test cases. We're going to do on the evaluation metrics and human calibration, some statistical tool, data science tool, and visualization. And weakness identification, we'll use some supervised machine learning techniques to do that, okay? The foundation, all of this thing that we're going to do, we're going to use embedding model to perform model validation. We're going to treat the system, the RAG system that we are validating as black box. We are not going to go inside the mechanism of whatever RAGs. We're going to treat them as a black box. We're going to interrogate it, and we try to explain it using embedding models. So embedding model is fundamental in everything we do here, from test generation all the way to every step in the model validation. All right. Let's start with the first one here in terms of comprehensive query generation and testing. Comprehensive query meaning we want to cover the entire document. We want to make sure we cover the entire document, and we're going to create query that is very diverse. We'll talk about this a little bit more detail. Query categories diverse that can do context handling, variability, robustness, and so on and so forth. Let's start with the comprehensiveness first. When we talk about comprehensiveness, we're going to start with our document chunk. We're going to look at we're going to do embedding. This is why we choose an embedding model, pick an embedding model to look at the document chunk. We're going to create embedding. Embedding is factor representation in high dimensional space. So to help us to understand better for interpretability, we're going to do dimensionality reduction and clustering. So we do dimensional reduction. Let's say my embedding is 1,000 something or 2,000 something dimension. We're going to, let's say, reduce it into 50 to 100 dimension. Then we're going to do clustering in lower dimension. And for each cluster, we're going to create topics. And then when creating topics, we can get help from LLM to summarize what topics in each cluster. In this example, I'm using OCC handbook on MRM as an example. And we chunk the OCC handbook on MRM, we chunk them and then we embed it. We embed them, create embedding representation, and then we do clustering. After we do dimension reduction, we do topic modeling, we do topic clustering. Then to do generate, now given this, we know all the content in the things that we need to validate. This will define the universe of tasks. From this universe of tasks now, we're going to do stratified sampling. The topic analysis here is very useful to stratify it. Once we stratify it, we're going to take sample for each strata. So this one will guarantee that we going to evaluate every topic. So the stratified sampling helpful to make sure that we have a comprehensive coverage. We cover every topic, and each topic will be represented because in every topic we're going to sample them, be it through random sample within that or through twinning sample. I like to use what I call as twinning sample. Twinning sample is basically smaller sample, but the distribution are the same distribution as the original, right? So that's what we call it as twinning. So maximizing, basically make the difference using energy distance. The two distribution are as close as possible between things that we sample and the things that the original. From that stratified sampling, now we can create test cases. From the sample, we are going to create Q&A pair. So we turning the document, the chunk of document, the summary of topics. We're going to convert it into important concept within that topic, and then from that important concept within that topic, we turn it into query. So that's where we use large language model to turn the topics from topics into itemized topic, and then from each item we creating query using LLM as a generator to with system prompt to generate. And we'll talk about that, what kind of query that we're going to do a little bit later. And then from the query that gets generated, we are automatic. We need to have measurement. How good is the query? We'll talk about that measurement a little bit later. Okay, now query we have the context, right? From each of the item that gets generated from the topic and sub item in topic. Now we're going to turn it into query. When we're going to turn it into query, there are many ways to do. We have query type. The first one, I call it context handling query. So we're going to create query that is really has the flavor of fact extraction query. The query need to ask question so that the answer will be to extract specific fact or detail from the context. query that will be answering a question about definition. So query to test the ability to explain or to define term. Procedural query to create query that is going to retrieve procedure. In banking, we have a lot of those because we probably have procedure, a process to do account opening, account closing, underwriting, and all of those things. So we need to third query that the answer will be procedural step by step. Analytical reasoning query, that's the logical analysis and synthesis to be able to synthesize. A multi-hop reasoning query from multiple item, multiple chunk. We need to generate queries that really test the ability of the system to integrate multiple information across different part in the topic. So it's variety of query that we need to generate. We also need to generate variability query. The objective is to test whether the system can generate consistent response with similar input, right? So we paraphrase the query, we repeated the query, refresh follow-up query, we do multi-round testing question and multi-turn asking follow-up, and all of those query that has a fine-grained detail query. The answer need to be repeatable and consistent to really test the consistency of the system to handle variability in the input query. Robustness query. We're going to test it with the ambiguous query, noisy, out of context, edge cases, and all of those. And if your document has numerical table of or chart, the query need to be able to really ask question that related to number query, looking the table lookup, looking at the chart, and cross-referencing table and chart, all kind of query that we need to generate on that. So here it is. To conclude on the test generation, we need to have comprehensiveness, cover all the chunk, all the topics in the document or collection of document, and then for each of those, we need to generate variety of query to test the ability of the RAG system. That's query generation. From query generation, now we test the RAG. We have test cases now. We have the ground truth. Remember, in this approach, the ground truth is the chunk. The ground truth is the chunk. We have the ground truth. We have query that we're going to ask, and then we have the output from the LLM that we're going to evaluate as well. So, but the ground truth that we use is the document chunk that we're going to use as the ground truth. With that, we have functionality evaluation, evaluate ability of the system to retrieve and synthesize and generate information based on user query. In that, it's two components in the functionality test. One is the retrieval ability, how well the system retrieve the chunk, the right chunk, the right information given the query. And then the second one is once we have the context, because the chunk we're going to use as a context to LLM to provide answer, we're going to evaluate the generation side, which is really a few things in there. Among them are groundedness. Make sure that the answer are grounded to the context, nothing made up, so not hallucinating. So groundedness is the opposite of hallucination. The other piece is completeness, that the answer has to be complete given the chunk that are presented. And this is important in banking, particularly if you have system to provide answer to the external customer, because if your information not complete, you may violate UDAP law. Somebody that has better information, they got more favorable interest rate than the other, then you will be in trouble. right? Or they get charged fee without knowing or something like that, then we will be in trouble because the law that we have that is in the banking environment, we have UDAP. You cannot get information has to be complete, not deceptive and misleading, right? So completeness is very, very important evaluation as well, not only groundedness but completeness. Answer relevancy is really between the query is the final answer, really answering the question in the query. So those functionality evaluation. The second type is really safety evaluation, safety or risk evaluation. This is typically we talk about toxicity, make sure that the answer is not offensive, harmful, or without using inappropriate language. The answer is not biased in terms of demographic or sentiment bias. And then, of course, the privacy, right? Protecting the privacy, no sensitive information will leak. So these are all the fundamental evaluation that we need to do. Now, how do we do it in this? We say we evaluate for context specific performance, for special usage. We don't do the general purpose evaluation. We evaluate for specific use case. We can tailor the metrics for critical outcome. We can focus on certain metrics more important than the other. Make sure that they avoid misleading conclusion. So this is the requirement for your query. Yeah. This is very important. Transparent and explainable metrics. This is why I am not in favor of using LLM as a judge, because when we use LLM as a judge, it's a black box. We don't know how LLM making decision. You can still even probably even if you ask LLM to give description, it can completely make things up. Nothing to do with the answer or the rating. So with the regulatory expectation, with audit, to make sure that we are confident. And so we want to have a matrix that is transparent and explainable. So I'll touch a few of those today. What are the example of transparent and explainable metrics? The simplest thing, okay, the simplest thing is using semantic similarity. For example, in the context relevancy, here's the objective is to measure how well we retrieve document given the query. So we can measure the similarity in terms of embedding. Remember, we use embedding of the query and embedding of the context. We're going to compare them. And we're going to compare them sentence per sentence. So you look at this in the matrix, we look at cosine similarity between query and embedding and document embedding sentence per sentence. So E here in my notation is a sentence, embedding of a sentence. We compare sentence per sentence. Every sentence we pair of every sentence, and we calculate them. Then we can aggregate them. For every if we are interested in for given question in the for given sentence in the query, how relevant the information that we retrieve. We can look at compare it all the sentences in the information, the chunk that get retrieved, and we take the maximum value. The maximum is the one that matches the most with the question, with the sentence in the query. Then we can average them across the sentences in the query, or take the worst score. We take the min max. We take the minimum score that is the worst in terms of context relevancy. Very straightforward. Using embedding, and we can calculate. Very straightforward. Is a dot product or sign similarity, and calculation is very straightforward. Answer relevancy. This is context relevancy between context and query. Answer relevancy is between answer and the query. We can do the same thing between the final answer and the query. Then when we look at groundedness and completeness, now we're looking at is the answer grounded to the context that we retrieve. So we can use cosine similarity to check and look at, is there any sentence in the answer that is very far away from the context? That's why the score is min max. Take the worst case. If you have a sentence that's very far away from the context, that sentence in the answer is it probably most likely hallucinate or made up, not grounded to the context. So that's one way to do it, using sentence similarity. We can also use natural language inference. Natural language inference basically classifier, looking at the two sentences, whether they are entailment, contradiction, or neutral. Because it's classifier, we can also understand it very, very easily. It's the final embedding. If the classifier, this is typically also a transformer types, right? As a classifier on language model, a transformer type, we can look at the final layer of the neural networks, right? The final layer, if you look at neural network, the final layer is always linear model. In the embedding space, in the embedding space, everything linear, right? So the final layer of neural network is a linear model. So we can look at the embedding. Again, we can visualize the embedding, like what I spoke about at the beginning when we do topic analysis. We can visualize the embedding in lower dimension. We can look at the distance to decision boundary. That the decision boundary is the really we express it in terms of probability, right? So we can see the distance to the decision boundary, so it's interpretable. We can understand it. We can visualize it through the embedding visualization. Completeness is the flip side of groundedness. Now we're going to look at every sentence in the context. Are they represented, captured in the answer? So we can do that as well. Now min-max, we do it as well. We look at it for every sentence, how well they are represented, and we look at the minimum score to measure completeness. That is, if we use sentence similarity. Alternatively, we can use a more holistic view, comparing distribution between the answer. Remember, every sentence define a point in high dimensional space, so multiple sentences will create a distribution. Similarly, on the context, we can compare the two distribution, distance between two distribution, using a measure like Wasserstein distance to measure how the degree of overlap between the answer and the context. That gives more holistic view, not instead of detailed sentence per sentence. If you look at detailed sentence per sentence, we may miss the nuance. Distribution will be complementary. Okay. I need to go a little bit faster here because of time limitations. Safety matrix is basically a classifier model. I spoke about classifier model before. We are using trained classifier, and we can interpret as well the outcome of that. Let me talk about the things that are very important. Calibration. Calibration matter because machine metrics, evaluation metrics, they are not perfect. I explained about sentence similarity and all of those things. None of them are perfect. Machine metrics is not human judgment. So we need a way to have trustworthy evaluation. So we need to, and this is important in regulated entity. Now, how can we calibrate between human judgment and machine evaluation? The simplest thing to do is by building for each matrix that we have. We are going to do random sample and have human label. So let's say take 5% sample or 10% sample. For example, we generate 1,000 or 10,000 test cases generation, and you can generate it automatically as we spoke before. using LLM and a variation of that. And then we're going to evaluate algorithmically using algorithmic evaluation that we spoke about. Those are all can be done at a very, very large scale because they are automated. Now we need to sample them. With the sample that we have with human label, now we're going to calibrate. So the step is we need to create calibration model. We have measurement from algorithmic measurement, groundedness or completeness, all of those metrics that we talk about, and then we have human label. If it's groundedness, you have score from 0 to 1. For example, if you're using similarity matrix, then we have human label, grounded or not grounded. Then we can calibrate them using as simple as logistic regression or use other technique like isotonic regression or monotonic XGBoost. You can create a calibration model that calibrate between the two. We can see the type 1, type 2 error when the machine evaluation and human evaluation disagree. And any disagreement will be good to check because human can be inconsistent as well. We can have a problem with reproducibility and repeatability with human evaluation as well. So it's good to do a cross check looking at the type 1 and type 2 error. And then we want to establish a confidence. This is where we use a conformal prediction. Conformal prediction is a statistical technique. Some of you that's not familiar with this, I highly recommend you to Google conformal prediction, a wealth of information out there to learn about conformal prediction is very, very useful techniques. So two main approaches that we can use. One is what I call it full conformal prediction. This is what I'm going to use. It's very, very simple. Well, I'll explain it a little bit on this. So what we do in conformal prediction is first is to calculate non-conformity score. This is human label. This is the output of calibration model. How we're going to calculate non-conformity, the residual, the difference between predict probability, between the probability output from that model to human label. That's the non-conformity score. And then from non-conformity score, we can sort them and take a quantile. Let's say 90% confidence or 95% confidence, take 90% quantile, 95% quantile. That's the threshold that we use. In full conformal prediction, we have a lot of samples that have no human label. So all the samples that no human label, we're going to do it one by one. We're going to create hypothetical label. Give label, in case of groundedness, give label grounded, okay? Give label grounded and see if I give label grounded, is it within the threshold of the quantile? If it's yes, that we can say with 90% confidence that is grounded. Okay. Now we put the hypothetical label of the other one, not grounded. See if it's within quantile. If it's within quantile, we say with 90% confidence. If the quantile is 90% confidence that this is not grounded. So with that, when we do that, the outcome of that exercise, you will have answer for each unlabeled sample. You can be ungrounded, can be grounded, it can be both. Not sure. It can be both, or I don't know, right? So it has 4 outcomes. And so the one that has only single entry, grounded or not grounded, we have 90% confidence, right? If the threshold is 90%. And the rest is something that unsure. Okay, and this what unsure it will when we do it, we can get the threshold of the unsure. So we can say in this example, if the value is bigger than such and such, I'm 90% confidence is grounded. If it's smaller than such and such, 90% ungrounded. So we can label the rest, the large sample that we have, with this calibration model. And anything that uncertain here, it will be worthwhile for human label, for people to human in the loop to look at them as well to see so that we can refine the calibration model. So that's the key points on doing conformal prediction. Now we have a threshold. We have threshold that we can use as guardrail in deployment because we have groundedness measure, we have all of those things. We can use this threshold as in deployment as guardrail, how we set the threshold. This threshold also useful now for model evaluation because we want to evaluate. I'm going to look at weakness identification. We want to look at the tail. We need to look at things beyond aggregate metrics. We cannot just look at aggregate metrics. We need to look at the tail. Let me give an example of that. So here it is, some evaluation. I pick one on the groundedness. The chart and the bottom left corner is groundedness, and every distribution is those are 1, 2, 3, 4, 5, 6 topics. Okay, I have 6 topics, and some topic the score are low. And from the conformal prediction, we can set up the threshold on this, what score constitute this, and we interested it really at the tail. This is marginal distribution. We're looking at it topic per topic. We look at which prompt that the model failed, the system failed. We can do similarly as well for query types, or we can do it simultaneously, topic and query type, looking at bivariate. We can also do clustering, to cluster using supervised learning with the target is groundedness. We can do supervised clustering, identifying region with low score, with where the failure. So we can see the cluster of prompt, the cluster of context, of the cluster of output that the model failed. So that's how do we identify model weakness. And from that, the final step that we want to do, of course, we have to do all the robustness tests that I spoke about. It's really now from the test cases that we have before, we're going to alter the prompt to make it more adversarial, to make it out of distribution, and per third term with the change of different thing, make it more ambiguous, make it lengthy, make it contradictory, make it misleading. So we alter all those prompts using with many different ways to see if the model will still be able to perform as intended. So I passed a little bit of my time. I think I have about 12 minutes here to do Q&A. I know I went this very, very fast. We did a workshop, 5 hours workshop, 3 hours workshop to on these topics, and we ran a few of this in the past. So next time around, when we have it, watch for that and join the workshop that go through a lot of detail how we're doing it with the hands-on exercise in Jupyter notebooks on how to execute all of this. So with that, Bruna, turn it back to you.
Okay, so we have a couple of questions, Agus, if you want to read yourself, but I can also read out
Can you
loud so
help me
everybody.
to
Of
read?
course, of course. So Patrick is asking, how can you assume RAG is the only source and not the original uncontrolled training data? Isn't that itself something we need to test, that it's pulling from RAG?
Um, my position will be no. Yeah, if we use foundation model, it is what it is. You have the best of humanity and you have the worst of humanity in the internet. So your model, your LLM is flawed from the very get-go, okay? Because you get the best and the worst of humanity. And you don't know what the training data in there, nobody, yeah, especially if many of those are not very transparent and you don't have that, right? So what we doing here is test for specific application. Now you bound it. You know, you start with foundation model that can go wrong. There's nothing you can do about it unless you want to build your own model. Okay, but people don't do that. Okay, so you're going to use foundation model that you have the worst of humanity and the best of humanity in there. That's given facts that we're dealing with today. So now let's test it using bounded. I'm creating bounded things. Make sure my tests are comprehensive with all the query type and all the topics. So this is what's important is really you bound it. And then here is one of the important piece in your guardrail as well, because you know this domain that what the model should operate only within this domain. Outside this domain, the model should not answer. Right? That's part of the robustness test using out of distribution. You test it out of that. Is the model going to just make things up? Or the model will be able to refuse. And that's very easy to do because a matter of calculating probability of membership to a topic. If it's the probability of membership to any topic is low, don't answer it. So yeah, the fact is, practical fact is we do not have how the data, how the model is trained. So if you don't have that, make sure that your test is conceptually sound. Your test is comprehensive and complete. Okay, next question.
So Vivek is asking, the retrieval system would have used similarity logic and perhaps a re-ranker to retrieve relevant chunks. Is the idea here to replicate that logic independently?
We test input and output, right? So in the rack retrieval, it can be so many different ways, right? Different chunking strategy, different embedding model, and different ranking model, right? Just for retrieval. We treat that as a black box. For as far as we know, we want to say, if I give this, am I able to retrieve information correctly? And and that's the most important piece is that evaluation of that. Am I able to retrieve, regardless whatever engineering and heuristic and anything that the tricks that people do within that? I am going to give input, I get the output, I'm going to see how good this one is. If it's not good, then you say, okay, what's going on here? It can be ranking system. If you have access to the ranking system, you can do that. You can do, if you want to do a model benchmarking, you can do model benchmarking, meaning that you create your own and you compare, right? But the idea is, can we test it as a black box without having to go to all the detail, whatever the specific things like that.
Great. Okay, next question, Andy. Thanks for sharing your insights with us, Agus. When leveraging LLM as a judge method to evaluate RAG, what are your thoughts on employing a mixture of experts approach?
I don't trust
Utilizing,
LLM as a judge. I don't trust
sorry?
LLM as a judge. Uh, you probably don't do mixture of expert. What you do is only averaging, right? Mixture of expert, you need to know the probability, right? For every sample, you weight it differently. That's mixture of expert. But if you just do simple average, that people do, you can do simple average and all of those things. A lot of research in this subject, LLM are biased against their own. And if I am in regulated entity, I will not use LLM as a judge. Or if you use LLM as a judge, compare it with something that transparent that I spoke about and calibrate it, right? Calibrate it with human calibration and compare with something. You cannot use LLM as a judge alone, because if you're in the US and you're in banking, you probably will be a sitting duck for the regulators.
Great. So Alfred is asking, this is a suburb roadmap you are giving us. As I am coming to this with the lens of the FRB SR 11.7 guidelines and requirements,
Mm-hmm.
validating predictive and risk models, What would you suggest as useful steps to help ease my way in the validation of GenAI models? Can you recommend or suggest additional
Yeah, the
material?
principle are the same. Yeah, the principle in model validation are really two components, right? Pre-deployment. I'm talking about pre-deployment. One is conceptual soundness. Two is outcome analysis, right? Conceptual soundness, because we don't have the data, we don't have inside the model. Conceptual soundness, the only thing we can do is make sure your test generation is conceptually sound, comprehensive, representative, and all of those. So conceptual soundness is very, very important in terms of designing the test. Secondly, is also understand, this is why I use embedding to get better interpretability. That's something that you can explain. So these are things that you will help you at least on the conceptual soundness. And then outcome analysis. Outcome analysis, I spoke about the different kind of prompt, variability, robustness, and all of those things, and identification of model weakness. And when I do prompt perturbation, is all of those are sensitivity analysis. So all the principle in SR 11.7 in terms of outcome analysis, you can do it here. In tabular data, we have variables. And value of variable, that's part of conceptual soundness. We do variable selection and all those things. We cannot do it in here. So our variable in here are topics and query types. Okay, topics and query types are our variable, so we test it with those accordingly. So use it as a principle, and you apply it for language model.
Great. So Sumant is asking, validation may not be domain experts. Then how do we make sure about the domain assessment and knowledge?
It's a very good question. This is why we talk about this is what is important to do this one. When we generate question, right? When we generate question, uh, we do it based on the ground truth, what's in there, and then you look at the question, the quality of question. You can do sample, you can do human review on that, right? So that's the human review. It help you on that, but also the scoring will help you. If you recall, this is what helped the lack of it's no substitute for domain expert. You need to have domain expert, but it's still helpful. When we look at we can go in very detail, look at groundedness, for example, and give you a low score. And then when you have low score, you can look between the query, between the context and the answer, and finding it. Okay, which one has the low score? Next time around, when we have time to do demo, we can give you demo on this tool. Hey, this help you for non-expert to look at it very, very quickly. Here is the context. Here are the answer. Are they matching? So that's something that you can do quickly. And in the calibration, my recommendation on the calibration is domain expert, right? So remember, we sample it, and domain expert is going to evaluate. That's what we do in the domain expert for calibration.
Great. Okay, we have time for one more question, and then we can answer. We did get a lot of questions, but we can answer them via email afterwards. So if your question was not answered here, don't worry, we'll get to you. So Andy is asking, what LLMs have you used in evaluation of interpretation of MRM guidance? If there are several LLMs, how do they compare?
For the purpose of what? Evaluation. You trust LLM to evaluate.
What
Yeah.
LLMs?
We LLM gave very wonderful, incredible answer on the subject that I don't know. On the subject that I know, 40% wrong. Okay, so that's when you deal with LLM, any LLM. Okay, they give you incredible answer on the subject that you don't know. On the subject that you know, many of those answers are wrong. Right? So we have to use LLM very, very carefully. They are incredible, they are very useful. So we have to steer it, we have to control it. They are only awesome and incredible on the subject that we don't know. On the subject that we know, I do use this a lot for coding. I use LLM a lot for coding. It's brilliant on something, but then it's terrible on other things. And that the thing is, this is exactly what we're trying to do here. We have to ground it. I am not asking LLM to answer a question. If you think about REG, I am using LLM just to write a good English because the answer is in your document, right? The answer is your document. From that given document, write it consistently in a very good English. No more than that. If we ask fact to LLM, we asking for trouble. The knowledge need to be in your database from your document, not in the LLM.
Amazing. Thank you. Thank you, Agus, for this great presentation. Also, thanks to everyone who joined us today. This session is being recorded. Many of you did ask if it's being recorded, if you're going to get the recording. Yes, you'll get it via email in probably tomorrow, and it will also be in our YouTube channel. So if you have any further questions, please reach out to us. I'll share the contacts via email as well. Have a great rest of your day.
Thank you.
You want to share, Agus, before we end it?
Thank you so much, everybody. And send the question. We'll try to answer it through email.
Yes. Okay. Thank you, everyone. Bye.